Hello everyone. In this new series of posts, we will discuss MBSE adoption use cases. There are a few reasons for that. There are common best practices, how MBSE gets adopted in the companies, and also there are some lower hanging fruits which are good to start working at when you start a journey to model-based digital engineering, because it requires some expertise, and better to start with some cases where you get the results faster. And also there is different directions, and it's not all or nothing. Model-based system engineering as part of model-based digital engineering and digital engineering in general, it's not all or nothing in general. There are many different directions, and in this series we will discuss those directions as paths to adopt, and one of the first ones, and maybe one of the most common ones to succeed, is product line engineering. And when do we address and get this direction as a valuable, successful story? Is when your system configuration is complicated, right? When your system is advanced, that's the most common case when you apply system engineering. But if you have some configurations, then you almost for sure would benefit from variance configurations, variance management, and that would be what we would do. And how to do it in SysML and CATIA, Magic, Cameo would be applying product line engineering concepts and solution. So that's the first case, and we will not go to complexities, which you can get that information from the links I will provide, but actually we will go to straightforward path where you will see how that is applied, and that everything is already there, everything is working, and you just start using and get results as fast as possible. So again, why? Because there are product lines, like you have not one product, but products are with some configuration. There are similar products, and you need to change configurations when you are producing, and do analysis, do documentation, do testing based on those different products. But you don't want to maintain separate design documents and separate architectures, because that will be 10 times more expensive than actually maintaining, or much more expensive than maintaining one single architecture with configurations for each of them. Samples would be like vehicle platforms, and vehicles in general, they change over a year, but also platforms and also software on those platforms are different, and you need to manage quite large complexity of single platform. But then when you go to the models, when you go to different software supplied configurations and vehicle platforms, that becomes really complicated situation where product line engineering is applied highly. Then another highly configurable products, it could be, like robotic surgeries, it could be, some configurable, satellites where you, like, say, CubeSats and others, where you have highly configurable products and you need to produce outputs. Client-specific configurations. So let's say that you have like 100 of possibilities to change something in the system, and each client can choose anything, right? So then you need to produce, you can't maintain those separate models, but you need to produce models on the fly for analysis, testing, and so on, like data centers and so on. Then complex architectures just with slight configuration. So if you have like really complicated system, you want to have ability to actually have dedicated models based on each configuration to test and to deliver to the designers to implement. But you can't maintain those separate configurations with every change in the architecture. Results: faster time to market, because you don't need to redo the architecture, you just change the automatically based on the features by transforming it. Then less errors, because separate architectures does not exist. They are based on a single architecture which is configurable, and you don't introduce errors, inconsistencies. Humans are no longer in the loop once you specify those variation points, and less resources needed to produce the final architecture. The resources are invested at the beginning to make it configurable, but that's like the good way to invest resources, because that's like a way to make it consistent in the later and less time-consuming later step. Now, so pretty much we deal with 4 types of models. We introduce, instead of working on different product-specific system models, we introduce actually 150% so-called model, which is covering all possible variations of your system. And then we introduce separate models like feature model, which is the smallest model, which just lists the features, what are the configurations possible, and what are the possibilities to change, and then also what configurations, typical configurations possible, right? Like premium, basic, models. Based on those features and those configurations, then applies for this 150% model, and by automatically transformed we get 100% model, which can be analyzed, can be tested, can be documented, can be published, and so on. And now in this demo we will actually show this most typical steps, typical scenario. We will show 150% architecture model. We'll choose deliberately like some functional model from business process modeling as user analysis, where we will be able to specify what alternatives we have in the system, in the future system. And then we'll create a feature model really fast, a small feature model, create typical configurations. We will assign features impacts based on those features, what should be changed in the architecture. Then we'll create branch in Teamwork Cloud to transform to 100% model. We'll do it to the branch, and then we'll publish to the Camel collaborator to see on the web and to communicate with the wider audience, clients and designers and testers to execute on that architecture. You can actually find all in-depth information inside of the MBSE community, which we manage actively, public MBSE community. Here you can find tutorial 1 hour. Here we see fast overview 1 hour tutorial, samples, sample projects, slides, papers, documentation, integrations, for example, with Enovia for import of feature models, and much more. In general, this is very public, very popular topic, and addressed in very similar concepts in the industry. So you can get familiar quickly and go to the required extent just by looking through that post inside of the Cyber Systems, MBSE Cyber Systems community. Here's direct link. So now let's switch to the demo. And here in demonstration, we have sample model, which is available from the samples, and it's called built-in Train Center, right? Train Center sample. And I will start from the business process modeling, actually from that could be activity diagrams, could be block diagrams, used. But here we have business processes, right? They are like use cases, right? And let's say I will decide that, okay, I want in my system architecture where I define, what would be, possible capabilities and how they are performed. I want some variations, and those variations would be that, okay, I have some actually variations that there might be no registration for the training center, so then I will eliminate those processes, and also there might be no cancellations in some product configuration, so I want to eliminate, let's say, those pieces, and that's the most simple way to start addressing variations, because you can actually just do like simple existence variation point, which is like, if true, if the feature is true, like registration should be available, then it will keep those elements. If no, then we'll remove, and as many elements as you want. So create element package, product line engineering, let's say, let's call it that, and then let's create another one, features, and one more, configurations. So in the feature model, I will create a class diagram. And by default, you will not see this root feature. That's the tricky part. You need to go to Files, use Project, and use MBPLE profile here in the project. And this profile is available as a result of this plugin, which is out of the box available. Just you need to select here product line engineering and download and install. It is no cost plugin, and it will introduce you generic capabilities for product line engineering. So now I can create a root feature group here and call it capabilities. And I can introduce, let's say, just no grouping, no extra complexity, just few features. For example, cancellation, which will be Boolean, true or false, cancellation capability, and new feature will be registration capability. So let's say I'm providing a product as a service which has some configurations, and those configurations is that, okay, user can be able to cancel the subscription to the training, or it could be registering by himself or not, you know, and I want to have this easily managed, right, instead of maintaining 3 different architectures or 4 different architectures. So okay, I have those features, right, and now I can create feature configurations. So here that's like would be instance table, would be this as a classifier, and would be 1, 2 configurations, premium, basic. So basic would be no cancellations, no registration. Premium would have everything, registration and cancellations. And we can create as many configurations as you want. Based on those features, you can group them to have typical configurations. Now here I can right click on any part of the elements, and could be multiple elements, and here go to variance modeling, and here you have multiple variation points. You can read about those documentation, but existence is the most common one. Like 90% of the variation points would be existence. Go to feature impact, choose the feature, go to list, choose the feature. For example, here is like registration, I think. Which was that registration. And I go to back here, and that's it, registration, close. And I can right click here, select in containment tree, and I see this. If I will delete this process, I will go here and remove all the containment in that process. So okay, everything what's related to that use case, to that process, will be removed. And now I again want to have and eliminate cancellation here. So I can just add on this branch in this behavior diagram, and it will remove automatically because those cuts are smart. For example, if I will cut some cancellation step here, it will remove this, but will reconnect and so on. So I right click here, variance modeling, existence, feature impact, and cancellation. Okay, and just wanted to cover one more thing. If you go here, you see in the existence, you can actually add as many elements as you wish. Here you can add other elements. You can actually include multiple elements which will then be affected by the feature change, feature selection, right? So you don't need to create those variation points manually. You just add one, you know, constraint element, actually not owner, constraint element Here you can add as many elements you want. Close. And that's it. You see here variation points. I can now choose the configuration. Okay, in this configuration basic, I don't have that. Can back and see here again in basic configuration, I don't have that. In premium configuration, I do have it. And so this here, nothing changed. Here I also have in premium configuration. Requires some time to refresh, but yeah, here you go, I have that. Okay, so now I could transform, but first of all, how that is actually would be done, like if I work in Teamwork Cloud, that was common scenario, right? I go here, open server project, and actually I'm creating a branch here where where I would select that branch, let's say from here, from version number 4, I would select and create branch, and that could be a basic branch. In that branch, I would now work, okay. You see that I'm automatically jumping to that branch where I confirm it's basic branch, right? And now open. And now in this branch, I'm actually going to transform to required configuration. So here we have this branch. Doesn't matter what I choose here. I can actually transform and see. I'm committing changes to server, collaborate, commit changes to server, commit. And now I'm creating branch. Basic branch, edit branch. Remove this old branch. Even this one. Basic. Here, create branch. Basic branch. Okay. Now I have basic branch, right? And okay, I'm switching to that basic branch. And this basic branch will be for me to maintain this published model, but I will not work on this variant on this specific configured model, because otherwise I will not be able to synchronize back to the reference architecture. So here is just one version based on this 150% architecture, which I don't want to manually update, right? I want actually to update this total project, and this variant configuration will not be updated. So now I will just transform and leave it as this tool, and then publish with that configuration. So variant serialization, this dedicated transformation here you see. Next, and here I will choose business process as a scope, and then next I will choose which configuration I want to enforce. As you see, I always go to the list, basic, okay, and then finish, and you see it's cut. And if I will go here, nothing changes, but here it's also cut. If I will undo, you see this was the variant configuration, and now it's gone here, right? And then if I go here, you see Control Z, Control Y, gone, right? And now I can actually publish that, collaborate, publish. Why I need branch? Because otherwise I would overwrite my changes in the main project. I don't want that, And why I want to publish? Because I want to publish, to commit to that branch, and also I want to publish to the collaborator, that everyone could view that. So I go to Tools, Cameo Collaborator, publish. I choose Training Center Basic, and then I can choose template, which could be BPMN, could be, you know, SysML based on the project type. I can enable, you know, editing, enable communication, you know, on that project, and I'm publishing. And once it is done, so as you can see, all is real time. This publishing takes sometimes more, sometimes less, but in general, we have optimized capabilities of image generation, so it is fast actually. I can open this document here in Cameo Collaborator, following the link, which you can give to anyone, you know, in your company and to partners to see the model, you know, as this. They can add comments, you know, you can collaborate, and this is just, you know, the best way to communicate your. Here we see the basic branch, and also soon we'll see published version. Takes some seconds to finalize. So now here we can see published model. As you can see, basic configuration, and we see this is basic model version. Here we can go to this process and open the process, and you see there is no branch here. We could also eliminate this element, you know, as automatically, and then it would be reconnected. Layout would not change, but actually it would be still, you know, automatically connected, and that would be like an amazing solution instead of manually updating every time you want some configuration. And yeah, now we can give this published model to anyone, you know, who has access. We can provide access through Cameo Collaborator, and that could be designers who will implement, it could be partners who will review this configuration, could be clients who will accept. They can actually give their feedback directly here, you know. They can click OK, say provide visual feedback, provide textual feedback, and that feedback we can get and act on it. And the most important, lesser errors, faster time to market, less resources. Thank you. And let me know actually if you see that on what type of systems you see there is like a big potential to apply it, or if you don't see, also let's discuss that.